All right, in this video, we are going to learn how to solve quadratics by factoring. So we've already learned all the component pieces to this. This is just putting it together. So let's jump straight in with an example. We're going to try and solve 5 equals 6x squared plus 11x minus 30. So there's only one variable in here. There's just an x. There's no y, which means instead of graphing this, we are just literally trying to find out what does x equal. We have one equation with one variable. We should be able to solve it. So we're going to do this by factoring and using the zero product property. In order for those things to work, it has to equal 0. So step 1 is to zero out one side. So we're going to subtract 5, so we get 0 equals 6x squared plus 11x minus 35. Step 2, we want to factor. You might look for a common factor first. So check out all 3 terms, see if they have a common factor. But either way, we're going to end up factoring with the box and diamond. So I'm going to set up. Why don't you pause and try and do this one? This is a tricky one. It's a good practice when the numbers get bigger. And then pause and you can watch how I did it. So I've got 6x squared minus 35. We're going to set up a generic rectangle. So 6 times negative 35, my calculator tells me, is negative 210x squared. And we know it's going to add to an 11x. So I need to think of multiples of negative 210. That's a big number. So whenever you have a number like this where all the factors aren't necessarily just going to come easily, I start far apart and then go closer. So like 210 and 1. 1 is always going to be your starting factor. What would go with 2? That would be 105. Does 3 work? Well, you can check in a calculator. It turns out it does. It goes in 70 times. That makes sense. 4 does not work. It gets a fraction. 5 does work. It gives us 42. 6 also works. We know that works because those were the numbers we used to begin with. 35. 7 looks like it should work because there's like 21s involved in here, right? So 7 gives us 30. 8 does not work. 9 does not work. 10 does work. That gives us 21. Sorry, 10 and 21. Notice as we go, these numbers are getting closer and closer and closer to each other, right? After 10, 11, 12, 13, 14 works. 14 and 15. And once these numbers are really close together, then we know that we've got all the factors, right? We're not going to catch any more because when we do 15, it's going to be back to 14 again. So we've got them all. Okay, so now we need to look. We know one of the numbers has to be negative, so we're trying to find a difference. These differences are all way too big. That one's too small. This one is going to give us a difference of 11. So 21x and 10x. And if I want the sum to be positive, that means the smaller number has to be negative. Those would multiply right. Okay, so 21x negative 10x. This gives me, that must be a negative 5 because that's a common factor there. If that's a 5, then this must be a 7. If that is a 7, this must be a 3x. So this must be a 2x, which works there, minus plus, this looks good. So 2x plus 7 times 3x minus 5. And it was equal to 0 in the beginning, so it's still equal to 0. That was a lot of work doing that factor step, but we did it. Okay, step 3 is to solve with the zero product property, just like if you're trying to find the x-intercepts of a parabola. Product property. So we're going to take each one and set it equal to 0 separately, because if one of them equals 0, then the whole thing equals 0. So 2x plus 7 equals 0, and 3x minus 5 equals 0. So we solve those, and those are going to give us two different answers, it looks like. So we're going to have two x values that work in this equation. So x equals negative 3.5 is one of them. And x equals 5/3 is the other. I'm going to leave that as a fraction rather than change it to a repeating decimal. So we've got two answers here. If this were a parabola, that would mean there were two roots, but it's not a parabola. It's just a quadratic equation. We are just finding x values that work in the original equation. Okay, solutions to the original equation. All right, now, remember, not all quadratics can be factored. So let's do another example and see what we should do when we run up into that situation. So this is example 2. Let's take 2x squared minus 4 equals 2. And let's try to solve that. So let's start the same way. Let's see if it's going to work. We're going to try and zero out one side. So 2x squared minus 6 equals 0. So far, this looks okay. This looks like some of the ones where that x value is missing, right? Some of those were difference of squares. This one is not, because it's not that would need to be like a 4 or a 1 or a 9. It'd need to be a square number there. Same with that. 6 is not square. So that doesn't work. Let's try and just factor it the old-fashioned way and see if that works. When we're missing a b value, we did a video on this, tricky factoring. When we're missing a b value, we just put in 0x down in the bottom. So let's look at our factors of 12. 12 and 1, 6 and 2, 3 and 4, 9. In order for there to be a sum of 0, they would have to be the same number but opposites, like one positive, one negative. And none of those are the same number twice, right? 12 is not a square number, so this isn't going to work. So we're going to say, nope, not factorable. Now, before we throw in the towel, though, I still want to solve this equation. Like, I feel like there must be a number that if I squared it, multiplied it by 2, and subtracted 4, I would get 2, right? Like, I feel like there's an answer here. So we also learned how to solve these by undoing the square. So when it's not factorable, we don't just give up. We say, try something else. In this case, we are going to try undoing the square. So let's start over. 2x squared minus 4 equals 2. In this case, we're trying to get the x squared alone, right? So we're going to add 4 to both sides. 2x squared equals 6. And divide by 2. X squared equals 3. Take the square root of both sides. And x equals plus or minus the square root of 3. So there are solutions. They are just irrational roots. So we've talked about this before. When it's not factorable, that does not necessarily mean there's no answer. It could be no answer, or it could be irrational roots like this one. So there's still two solutions, just like there was also two solutions up here. We know sometimes there's one, sometimes there's two, sometimes there's none. And there's more methods we can try, like undoing the square. We just haven't learned them yet. All right, practice problem time. So for your practice problem, please solve for x. In the equation, x squared minus 4x minus 15 equals negative 10. Use any method that is not Desmos, so no graphing. You have to do this algebraically.